All right. Happy day. Happy video. Here we go. Today, we're talking about perpendicular bisectors and angle bisectors. Now, I like to call this cat day. Okay. Mr. Wilhelm doesn't know what cat day is yet, but he's going to find out here pretty soon. I like to call this cat day for a lot of reasons that we'll get into as we go along. Okay, you'll start to see why eventually, okay, as we go. All right. So what does it mean for points to be equidistant, in which ones? Well, if I have a diagram like this and I marked it like so, okay, I could say that P and O are equidistant from N. Okay. I could also, excuse me. Sorry about that. That was a quick pause. So anyway, I'll keep going. I can also say if I had a diagram like this and this, that C and D are equidistant from B and A. I could have it like this. Same idea. C and D are equidistant from both A and B. Okay. Now, what does that mean? What does that mean? We'll get into what that means. What that tells us in a minute here, but this is a very important idea. Okay, what is that? Obviously, you can see that equidistant means that they're congruent. Okay, these points CA is congruent to DA, CB is congruent to DB. Okay, equidistant means they're the same length. They're equal in distance. Okay, let's keep going with another picture like this. If I had something like this, the same idea would apply. All right. Why is it cat day? Well, if you look here, there's kind of a cat in here with the whiskers, okay, and stuff. It kind of looks like a cat, right? Here's the nose and stuff, and here's the mouth and teeth, and so it kind of looks like a cat. You got the ears and the whiskers. Now, I'm not one for always for tricks, but I think that cats. All right. So 2 points are equidistant if they are the same distance from the third and fourth point. Okay. So in all diagrams above, A and B were say to be equidistant from point CD. Okay. Endpoint C and D of segment CD. Therefore, AB, this is a big thing for today, is called the, you can read my handwriting, perpendicular bisector. What does that mean to be a perpendicular bisector? All right, well, we'll get into that on the next slide. So again, whoops. Something like, all right, we have these and these. So A and B are technically equidistant from C and D. All right, let's keep going. So a perpendicular bisector, what the heck? Sorry, a perpendicular bisector. So remember we mark perpendicular with the upside down T like that. Okay. The upside down T. All right. It's the line that bisects. I gotta just type this out. And is perpendicular to a segment. If 2 points are each equidistant from the endpoints of a segment, then those 2 points determine the perpendicular bisector of that segment. What do I write down for you? All right. I would say if equidistant points, then perpendicular bisector. All right. That's if you wanted to shorten it, that's what I would do. And if a point is on the perpendicular bisector, again, and you can also remember to use that upside down T symbol instead of writing out the word. Save you some time. Use that notation. Then, if a segment is on the, then it is that segment. So what does this all mean? It's a lot of words, a lot of complicated words. Let's put it into practice, okay? So DF is a perpendicular bisector to EG. So D, that tells me right away. Here's my trick. That tells me DE is congruent to DG. And FE is congruent to FG. I got my ears and my whiskers. Anytime you see perpendicular bisector, I think ears and whiskers. Okay. Now, one of my students, when I first started teaching, so a long time ago, not that long ago, only about 6 or 7 years ago, back in 2014, said, I can go one first letter to the third, first to the fourth, second to third, second to fourth, 1 to 3, 1 to 4, she said, 2 to 3, 2 to 4. I thought that was interesting. I kind of liked it a little bit, so I share it every year. So let's say this DE is 8x plus 5, and this is negative 2x plus 15. Well, what do we do? If they're both the ears, that makes them congruent. Add the 2x, subtract 5. I got 10x equals 10. X is 1. Wow, that was not too bad. Okay. The biggest part, the hardest part about this is recognizing and labeling the actual picture itself. Okay. Obviously, you can always draw in the eyes, the nose, and the mouth if you want to draw in your cats. Okay. So let's keep going. AB, now we have a triangle on the side. Okay. Doesn't matter. Okay. That still means that A to C is congruent to AD. And BC to BD. So now we got a cat taking a nap. All right, the cat's taking a nap. Good night, cat. Good night. Enjoy your nap. Enjoy your nap. So I got x squared plus 7x. That's. And then 5x plus 15. Wow. What should I do? Oh, I got 2 pairs of ears. Oh, I should set them equal. X squared plus 7x equals 5x plus 15. Hey, it looks like we might have to factor here because we have a square term. Maybe you should move everything to the other side. So let's move everything to the x squared side. So I'm going to subtract the 5x and subtract the 15 so that I have x squared plus 2x minus 15 equals 0. I want two numbers to multiply to negative 15 and add to positive 2. X plus 5, x minus 3 equals 0. This tells me that x is negative 5 and x is 3. How do I get that? Remember, zero product property states that I can set each factor equal to 0 like that. Okay? Now it's on us to figure out which x actually works, or do they both work? Well, obviously, I'll just test the negative first. If I plug negative 5 in here, I'd have negative 5 times 5, which is negative 25. Negative 25 plus 15 is not going to be a positive number, so I can throw out negative 5. Okay? 3, if I plug it in, 3 times 5 is 15, plus 15 is 30. 3 works. X is 3. Wow, that's pretty neat. Don't you think? I think so too. All right, let's keep going. I'm having way too much fun today. So are all of you. I can just tell in your faces. Let's go. Now, what would I write down if I were you here? Okay, I don't want you to write down all of this. All right. What I would write down though is, let's see, let me underline some stuff for you here. Okay, if a point lies down the bisector of an angle, then is equidistant from the two sides of the angle. Yeah, I would write that whole thing down. Actually, I'd write all that down. It's just a simple sentence. I just covered it. I would write that down and give yourself a diagram. Okay, that tells me that these two segments here are congruent. All right. And again, this must be the angle must be bisected, and these two we must have right angles right here. And I can also use the converse to say that these two angles are then congruent. You can also just say and vice versa. Okay. And draw the picture of. All right. I would definitely make sure you have that down. That's important. Okay, it is important. I apologize. It's a lot. You maybe don't need this or this, but I would definitely make sure you write down each of these things, especially the first one. If you want to shorten that or vice versa it, or say and flipped also is true, that's fine. It's up to you. These are your notes anyway. Let's keep going. So find the measure of each angle, or find each measure. There you go. So I can see right away that this AD is congruent to CD, and BAD and BCD are both right angles. Okay, well, that means I'm looking down here. I have right angles, and I have two congruent segments. That means these two angles have to be the same. So if CBD is 56, then DBA is also 56. So these two here are congruent. I'll make that red, actually. So these are the same. Well, if these are the same, that means this is 56. So the measure angle ABC is just going to be 12. Now, this only works if I have congruent segments and right angles there. Only time that happens. Let's talk about the flip of this. Okay. I have two congruent angles and I have two right angles. Well, then that means that these are congruent. So if they're congruent, I can set them equal to each other. There's a reason I chose this problem, because I want to, we want to review this x plus 2 squared and how we tackle that. All right. X plus 2 squared is not x squared plus 4. It's not. X plus 2 squared is x plus 2 times x plus 2. Okay, remember how, like 3 squared is actually 3 times 3, or 9, obviously. 4 squared is 4 times 4. 5 squared is 5 times 5. Same thing. If I square something, I have to write that thing twice. It's that thing multiplied to itself. I don't just distribute the exponent. That doesn't work. That's a common mistake that people make all the time. So I get x squared plus 2x plus 2x plus 4 equals 2x squared plus 7x. Combine my like terms on this side, x squared plus 4x plus 4. You may have done that step in your hand. That's totally fine. Move everything to one side. So I'm going to take this x squared, move it over here, 4x, and the 4. So I have 0 equals x squared plus 3x minus 4. Two numbers that multiply -4 and add to +3. X plus 4, x minus 1. That's equal to 0. Zero product property says that x equals -4 and x equals 1. I can set each factor equal to 0. And again, you can do this part in your head. I just want to show that step. So x is -4 and x is 1. All right, so the question is, which value works? Well, if I want to find Jm, they actually both work. All right, they actually both work here. Both x values work. So Jm can have two values. -4, that's 2 squared. 2 is 2. 2 squared is 4. And Jm is going to be 1 plus 2 squared, which is 3. 3 squared is 9. So Jm has two lengths. Possible. You can do that. That's why you have to test the negatives. That's why we test our negative values, okay, because they both work. All right, that's it for the video. Adios.